Hey guys, welcome back. In the last two videos, we spoke about limits from the left and limits from the right, and limits as x approaches infinity. And now what I'm going to do in this video is just put everything together and clear up any misconceptions that one may have. Okay, I'm going to start off with this function. It's a parabola. We know that this parabola has no problems in it. In other words, there's no points that are discontinuous. And one way of recognizing it, obviously, is just by imagining a parabola. There's no place where I would pick up my pen other than drawing those arrows. But there's no holes in the graph. There's no infinite discontinuity, right? There's no vertical asymptote. So I don't have to worry about limits from the left or from the right because the limits will end up existing. And so what I do in this case is when I read something like the limit as x approaches 2 from the right of this function, all I have to do is sort of ignore this little plus sign here because I know there's no problem at 2. So I just plug in the 2 regularly and remind yourself that this is going to this is what this is really saying is what happens when I get really, really close to 2, but just a little bit more than 2, like 2.000001. Okay? So 2 squared is 4. That's 8. That's 8. That's 3. 16 minus 3 is 13. That's all. Once again, what is the limit as x approaches 3 from the left side? Well, when x approaches 3, I know there's no problem at 3, so I don't have to worry about limits from the left or from the right. I just plug in the 3. Okay, so let's see. That's going to be this. And that's going to be 9, 18, 12. That's 30. That's 27. Wonderful. What about the limit as x approaches 0 from the right? Once again, there's no problem at 0. So whether it's from the left or from the right, you just plug it in. And I know that answer is going to be a minus 3, right? Boom, boom, minus 3. So if you take a look at this parabola and you take a look at a little bit more than 2, a little bit less than 3, a little bit more than 0, you'll see it's approaching 13, 27, and negative 3 respectively. Next one. Okay, now I have a function and I have a fraction. And these are the ones that make me nervous. Now, in this problem, the only problem that I have is x equals 4. Okay? If it's something other than 4, I have nothing to worry about. I just do direct substitution. So in this case here, I'm looking at 3 from the left. Great, I'm just going to plug in 3. 3 squared minus 16 over 3 minus 4 is 9 minus 16 is a negative 7 over negative 1, and that's going to be positive 7. And you're done. Just a friendly reminder from a few videos ago that x squared minus 16 divided by x minus 4 can reduce by factoring out the numerator and then crossing it off with the denominator to this x plus 4 function. Remember, we talked about this. This and this are exactly the same, except for you have to make sure you tell the reader that x cannot equal 4. Now, when x cannot equal 4, there's a point discontinuity because we were able to factor and cross off. So what is that point? 4, comma, I got to plug the 4 into here, 8. Okay? So, but that doesn't help in this problem because I'm looking at x approaches 3 from the left, but I think I rewrote this problem for later. So let's keep going. The limit as x approaches, f of x equals 2 over x minus 3. The only person who does not work is 3. So somebody before 3 or somebody right after 3 is not going to work. So you're going to have to basically analyze it, okay? So the limit as x approaches 3 from the left, that's just basically saying what would happen if you put 2.9999999 and so on, really close to 3, but just a tad bit under it. Well, if you plug that in, you get 2 over negative 0.000000, lots of zeros over 1, right? Isn't it true that if you end up plugging this number in here, 2.99999 minus 3 is negative 0.00. So 2 over a very, very, very small number is extremely large. So that's infinity. And because it's negative infinity. Okay? So this is negative infinity. Limit as x approaches 3 from the right means 3.0000. Remember, limits is not what happens at 3. It means what happens when you approach 3. So when you put 3.0001, you get 2 over 3.0001 minus 3. And that's 2 over positive. And so that's going to be positive infinity. If one were to graph this, you would see that this graph has a vertical asymptote at 3. Okay, so I'm just going to do this. And a horizontal asymptote at 0. If you guys remember why, the denominator has an x while the numerator doesn't. And what this means is, here's 3. 3 from the left, I'm going down, right? Negative infinity. As I approach 3, when I get closer to 3, I go down here. As I approach 3 from the right, I go like this to positive infinity. So that's what that graph looks like. Okay? Let's try now x squared minus 16 over x minus 4. The problem that I have here is x cannot be 4. If I'm using any numbers other than 4, I just plug it in. But now that I'm using 4, I can't. So when you go to plug in 4, in this previous problem, the numerator had no x's. So I just plugged this number into where the x is. Here, the numerator has an x. So basically, when you plug in 4, you get 0 over 0. That tells you to factor. You should always do direct substitution first. So you get x minus 4, x plus 4, all over x minus 4. You cross it off. We discussed this a few problems ago. Now, this function is exactly this function, except for x cannot equal 4. Well, what would happen when you plug in 4? What's going on? What's the problem with this graph? There's a point discontinuity. Well, what's the point? Well, let's find out. We're going to plug the 4 in here. When you plug in 4 in the rest of this, you get 8. In other words, this function, this guy right here, is really him, which is a line with a y-intercept of 4 and a hole at 8, which means limit as x approaches 4 from the left, you plug it in here. 4 from the left means 3.99999. 3.99999 plus 4 is 7.99999. It's approaching 8. 4 from the right, 4.0001 plus 4 is 8.001. Approaches 8. So that's how we do that. Okay, the only person who doesn't work is x equals 1, right? That's the only guy I have to worry about. So this first guy says, what's the limit as x approaches 3 from the left? I don't care that's from the left. Just plug in the 3. 5 over 3 minus 1 is 5 over 2. You're done. Now I care because it's 1 from the right. So I got 5 over 1.000. Sorry, 1 minus that guy. That's going to be 5 over positive 0.0001. That's positive infinity. And then 1 from the left is going to be 0.9999 minus 1. That's negative infinity. Okay? And here's my last example of the day. I already did this. X approaches 2 from the left. 2 is the only guy that I have a problem with. So I put 1.9999 in the numerator. Once I take the square root of 1.999, I get some value that I don't care about. 1.9999 minus 2 is negative 0.001, which gives you negative infinity. And that's pretty much how you do it. If you have any questions, you can leave them in the comment box. Subscribe, say hello.